Hi everyone. So in this video, I will be sharing about the Neo4j database system. Neo4j is a graph database system and it stands out as a very powerful tool, famous for its ability to handle complex relationships and interconnected data structures. So I'll be going through the basics from how we can create and load the dataset into the database, okay, and also perform some simple queries on the dataset itself. So I'm a huge football fan of the English Premier League, in short EPL, and I have created this graph database schema representing the football players, okay, the coaches, the teams, okay, and also some of these relationships over here, okay, like the teammates, who are their coaches, the teams they play for, okay, and also the teams that they have played against. Okay, so this data set also includes information such as the player's name, their age, their jersey number, and also their height. Okay, and of course, the coach's name and the team name. Particularly for this place for relationship, I have also added some additional property to this relationship, okay, such as the weekly salary of the player. Okay, and then for this played against relationship, okay, there are also some other properties such as the minutes played by the particular player, okay, and also the number of goals and the number of assists that they have created during the game. So of course, this is not the full entire data set of the English Premier League, okay, but this data set should be enough for me to perform some simple queries on the Neo4j database. All right, so without further ado, okay, let's proceed to try and load this data set into the Neo4j database system. Okay, so this is the Neo4j browser, okay, and I will not go into how to install the Neo4j into our personal computers because I think that is that can be easily found from other tutorial videos. So let's try and load the dataset that I have created earlier on. Okay, and to do that, okay, one way, okay, is to actually copy and paste the entire cipher code that I have written, okay, onto the command line over here, okay, and press the play button to execute the code. Okay, so it tells us that I have added 24 labels, created 24 nodes, set 216 properties, okay, and created 90 relationships, completed in 10 milliseconds, which is kind of fast, okay, and expected because of the relatively small data sets that I have. Okay, so now that we have our data set loaded into the database, we can actually proceed to write some queries on it. Okay, and in order to cover more content within this short video, I have decided to pre-write and also pre-execute the code so that I don't have to spend too much time typing in the codes. Otherwise, I think the video can go on for a very long time. Okay, so the first thing that I think people usually wants to see from a dataset is an overview of the graph data structure. So to do that, they can actually type in the code over here, match n, return n, and proceed to execute the code. So this will return us the overview of the graph data structure. So match and return, okay, they are the keywords. Okay, and what this line of code means is that we are trying to match all the nodes, okay, and asking it to return all the nodes in their relationships. So if I try to click on one of the nodes, there's a panel on the right over here which will tells us the node properties, okay, and it tells us that this belongs to the coach node, okay, and this is the label, okay, of the node. Okay, if we click on the purple one, okay, this is the player nodes, and if I click on the blue one, this is the team nodes. So all these nodes, okay, we can see that they are clearly differentiated by different colors, which is very nice. Okay, and if we try to zoom in a little bit, okay, we can also see the relationships, okay, that are interconnected between the nodes. So we have the coaches relationships, we have the plays for relationship, and play against relationship. Okay, so sometimes we may just want to look at one specific node, for example, the player node. Okay, and we are not interested in the teams or the coach node. So to do that, okay, we can actually type in this code over here, okay, match player colon the label, okay, and return player. Okay, and if we execute the code, okay, it will return us only the player nodes. Okay, so if we click on one of the nodes, okay, it will tell us that this is a player node. So if I zoom in a little bit, okay, it also returns us the relationships, okay, among the nodes, okay, if there is any. So in this case, this player, okay, is a teammate with this player, Bruno Fernandes. Okay, so the other thing that I would like to highlight, okay, is that when we are typing in the code, okay, as we press the colon key, okay, the list of labels will actually show up, okay, and we can actually just select the label that you want, okay, which makes it very convenient for us. Okay. Okay, so similarly, we can also do this for the coach notes and also for the team's notes. Okay, so for the coach, okay, we can key in this note and execute the code. Okay, so it will return us only the coach notes. Okay, and in this case, there are no relationships between any of the notes. Okay, and if we do it for the teams, okay, and we run it. So again, it will return us just the team's nodes. Okay, and again, there is no relationship between the nodes. Okay, so the next thing that I would like to show is that we could also fetch specific properties, okay, instead of the node. So for example, let's say we want to fetch all the player names in this data. Okay, we can type in this code over here. So the key difference is over here, okay, where we will type in dot name, okay, to fetch for the specific property, okay, compared to the previous code over here, okay, where we just ask it to return the team, which is the node. Okay, so if we proceed to execute this code, okay, it will return us the player names, okay, all the player names in a table format. We can further expand this, okay, to fetch more than one property. Okay, for example, if we want both the player names, okay, as well as the player height. Okay, so we can just add on to the code, okay, comma, followed by player height, okay, and proceed to execute. So now we have the player name as well as the player height, okay, in this table. Okay, so let's say we do not like the column header names. Yeah, we can actually change it. Okay, we can simply add in this, okay, player name as player, okay, and player height as height, okay, and proceed to execute the code. Okay, so now we have the column header as what we define, okay, player and height. Okay, let's say now we want to get a node of a specific player, for example, the Erling Haaland node. Okay, we can actually type in this code over here. Okay, and the key difference is that now we have this where clause, which will help us to specify the condition that we need. Okay, so in this case, okay, we specified that the player name has to be equals to Erling Haaland. Okay, and it is important to note that the capitalization of this string is important. Okay, it has to follow exactly what is written in the node properties over here. Okay, so if we click on the node, we can also expand it to see all its relationship with all the other nodes. Okay, so we can also have multiple conditions. Okay, for example, we want to get the Erling Haaland node, okay, whose height is 1.9 and age is 23. So what we would need to do, okay, is to add in two more lines of the code over here, okay, using the and keyword. So the player age is equal to 23 and the player height is equal to 1.94. Okay, and if we proceed to execute the code, okay, as expected, okay, it would return us back the Erling Haaland node. So note that all three conditions have to be met, okay, since we are using the and keyword, okay, in order for this node to show up. If I change the player height condition to 1.93, okay, and I execute the code, okay, then no results will turn up because there's no such player whose name is Erling Haaland, age 23, and has height of 1.93. Okay, so we can actually rewrite the previous code in another way, okay, using the curly brackets. So this code only requires 2 lines, whereas the previous one requires 5 lines. So perhaps this is neater and also more readable. Okay. Okay, and if we want to return all the players except for Erling Haaland, okay, we can use this not equal sign over here. Okay, and if we proceed to run the code, okay, it should return us all the players, okay, except for Erling Haaland. Okay, so you realize that okay, so Kevin De Bruyne was a teammate of Erling Haaland, so now he's not appearing in the node over here. Okay, so moving on, let's say now we want to return all the players whose height is taller than 1.9 meters. Okay, then we can have this code over here, okay, where we specify the player height to be more than 1.9 meters. So if we execute the code, okay, it will show us all the players that has a height of more than 1.9 meters. Okay, so if we want to do a check, okay, on it, you can click on the node and go to the node properties. So Scott McTominay has a height of 1.93, which is greater than 1.9. Okay, Erling Haaland has a height of 1.94, which is greater than 1.9. And Virgil van Dijk has a height of 1.95, which is also greater than 1.9. Okay, so we can also specify multiple conditions. So for example, over here, we want to return all the players who has the age of more than 26 and has a player height of less than 1.9 meters. So if you run this code, it will return us all the players that met both the conditions. So for example, if you look at Bruno Fernandes, age 29, which is greater than 26, and a height of 1.79, which is smaller than 1.9 meters. So because he met both conditions, that's why it appears in the output. Okay, so sometimes in a very huge data set, okay, if we execute this code, then there many nodes would appear. Okay, and it would be very hard for us to actually analyze the data with so many nodes appearing in the graph. Okay, so if that is the case, okay, we can actually use the keyword limit, okay, to limit the number of nodes that we want to see. Okay, so in this case, okay, we have limit the number of nodes to 2. Okay, and if we execute the code, okay, it will only output the two nodes that met all these conditions. Okay, but this wouldn't make much sense unless we know what the results are ordered by. So we can actually type in order by player height followed by limit 2. Okay, and if we run this, okay, it will return us two players, Mohamed Salah and Raheem Sterling. Okay, and by default, okay, it will output the results in ascending order, and we can actually check the ordering, okay, from the table tab over here. Okay, so for example, Raheem Sterling has a height of 1.72. Okay, so this is the first output. Okay, followed by Mohamed Salah, which is a height of 1.75 meters, which is the second output. So we can see that it is in ascending order. Okay, so if we change the limit to 3, okay, so the third player that comes out should have a height that is greater or equals to 1.75. Okay, so we can test it out. Okay, over here. Okay, if I change the limit to 3 now, okay, and I execute. Okay, so previously we have Mohamed Salah and Raheem Sterling. Okay, and now we have the third player, which is Martin Odegaard. Okay, we can quickly see that this is 1.78, which is larger or taller than the 1.75 meter that we have previously. Okay, so if we look at the table results output, okay, 1.72, 1.75, followed by 1.78. Okay, so we can also order the player height in descending order by adding the keyword DESC over here. Okay, and if we execute the code, okay, it returns us three different players. So if we go to the table, okay, now we have Virgil van Dijk at 1.95 meters, Scott McTominay at 1.93 meters, and Son Heung-min at 1.84 meters. So it is being arranged in a descending order now. Okay, so what I have just covered, okay, in this first part of the video, okay, talks about how we can actually perform filtering on the nodes. Okay, so in the next part, okay, okay, I will talk about how we can query on the relationships itself. Okay, so let's say now we want to find out who are the players who plays for a particular team, say Manchester United. Okay, we can actually key in the code over here. Okay, so the key syntax is actually in the first line where we match the player node, okay, that has a place for relationship, okay, with the team node. Okay, and we have a where clause that specifies the condition, okay, which in this case we want the team name to be Manchester United. So if we execute the code, okay, it will return us all the players who played for Manchester United. So notice that the graph is not showing the Manchester United node. Okay, so if we want to show that, okay, we can actually add it in here. Okay, at the return keyword, the teams, and we execute it. Okay, so now we it's clearer. Okay, we have the two players, okay, that plays for Manchester United. Okay, so next, remember at the start of the video, I actually mentioned that within the play for relationship, okay, there is this information of the player's weekly salary. So if we click on this relationship, okay, we can actually see the salary, the weekly salary of the player, okay, this being displayed over here. Okay, so we showed that nodes, okay, can have properties. Okay, we also show that relationships can also have properties. Okay, so in the next query, okay, we want to query for all the players that have weekly salary of more than 350,000. Okay, and to do that, we can write in this code over here. Okay, so we match the player node that has a place for relationship with the team node. Okay, and we have a where clause that specifies the condition where the salary is more than 350,000. Okay, and we ask it to return the player as well as the team nodes. Okay, and if we execute it, okay, then we would get all the players that has a salary of more than 350,000. Okay, so and these two players are Kevin De Bruyne and Erling Haaland. Okay, and both of them plays for the Manchester City. Okay, so next, I would also like to quickly talk about how we can perform aggregation. So let's say we want to return the player names as well as the number of games they have played. Okay, and in order to determine the number of games played, okay, we will need to make use of the play against relationship. So we can type in this code over here, okay, where we match the player node, okay, that has a played against relationship with the team node, okay, and ask it to return the player name and count the number of games played. So if we execute this code, this will return us with all the players, okay, and the number of games they have played. Okay, so earlier on, I also showed that in the played against relationship, there are some properties such as the minutes played by the player, the number of goals, and the number of assists created by the player during the game. So we can also perform an aggregation on these properties. So so let's try and get the player names, okay, and their average number of goals per game, as well as their average number of assists per game. Okay, so to do that, okay, we can key in this code over here. So we can match the player node, okay, with the played against relationship, okay, and the team to the team node, okay, and then the player name, okay, we use this aggregation function avg to get the average number of goals, okay, as well as the average number of assists. So if we proceed to execute this code, okay, we will get back all the players together with their average uh, number of goals per game, as well as the average number of assists per game. Okay, and if we want to sort them from the highest average number of goals per game, okay, we can modify the code, okay, and add in this line order by average games played dot goals, okay, in descending order. So if we run the code, okay, now we can see that the results are being on in descending order, okay, in terms of the average number of goals per game. Okay, so we have 1.0, 0.5, 0.5, 0.4, 0.4, and 0.25. Okay, so in the last part of this video, I would like to talk about how we can delete a node, delete a relationship, as well as deleting the entire graph. Okay, so if we want to delete a particular node, okay, so let's say over here, we want to delete the Bruno Fernandes player node. Okay, we first have to specify the where condition, okay, in this case, the player name equals to Bruno Fernandes, okay, and then followed by detach, delete player. Okay, so if we execute this, okay, then it will tell us that it has deleted one node, okay, deleted 8 relationships, okay, in 26 milliseconds. So the detach keyword is important here, okay, because if we don't type in the detach keyword, we will encounter an error, okay, because Bruno Fernandes, the player node, has multiple relationships with other nodes. We can't just delete the player without deleting its relationships. Okay, so now if we want to check whether we have deleted the player node, okay, we just key in this code, we match the player node and return all the players. Okay, we can see that Scott McTominay, okay, originally he has a teammate which is Bruno Fernandes, and now he is not appearing in the graph. Okay, so if we want to delete a particular relationship, for example, Erling Haaland no longer plays for Manchester City. Okay, we can actually key in this code over here. So we match the player node using the play for relationship to the team node. Okay, and we specify the where condition, which in this case the player name equals to Erling Haaland, okay, and the team name equals to Manchester City. Okay, and what we have to do is to delete away the relationship, okay, which we actually specify over here. Okay, so if we run this code, okay, again it will tell us that it has deleted one relationship completed in 9 milliseconds. Okay, so we can again do a check on this, okay, uh, by writing in this code. Okay, so we match the player node, okay, with the play for relationship, okay, to the team node, okay, and specify the team name to be Manchester City, and then we return all the players and the team. So now we have this, okay, the Manchester City team, and there's only one player, okay, who is Kevin De Bruyne, who plays for Manchester City. So the relationship between Erling Haaland, who or initially plays for Manchester City, is now no longer in the graph. Okay, and finally, we can also delete the entire graph, okay, by having this code. Okay, so match n, detach, delete n. And if we execute the code, it will tell us that we have deleted 23 nodes, deleted 81 relationships. All right, so that's all I have for this video. Thanks for watching.